Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are going to start mathematics for class 11, which is algebra and trigonometry. We will study its chapter number 7, which is permutation, combination, and probability. Today is our lesson number 1, and in this lesson, we will study factorial notation and permutation. And we will solve the selected questions of exercise 7.1 and 7.2, which are included in your smart syllabus. Factorial notation. What is factorial notation? Let n be a positive integer, then the product of all the numbers starting from n to 1 is the factorial of this number, and this is denoted by n, and after this number we put sign of exclamation, or we write that number in this type of box, and this is read as n factorial or factorial of n. So simply n factorial is the product of all the numbers starting from n till 1. 1 factorial is 1, 2 factorial mean the product of all the numbers from 2 to 1. This is equal to 2. Or 2 factorial can also be written as 2 into 1 factorial. 3 factorial is equal to 3 to 1, product of 3 to 1. This is equal to 6, or this can be written as 3 factorial equals to 3 multiplied by 2 factorial. You can stop writing the further numbers by putting factorial notation with that numbers. 4 factorials mean the product of 4, 3 to 1. This is equal to 24, or 4 factorial can be written as 4 multiplied by 3 factorial, or 4 multiplied by 3 multiplied by 2 factorial. 5 factorial is the product of 5, 4, 3 to 1. This is equal to 120, or you can write 5 factorial is equal to 5 multiplied by 4 factorial, or you can write 5 multiplied by 4 multiplied by 3 factorial, or you can write 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial. You can stop at any number, but you will have to write the sign factorial sign with that number. Similarly, 6 factorial is 720. N factorial, as we know, it is the product of all the numbers starting from n to 1, or you can stop at anywhere. The n multiplied by the smaller number to n is n minus 1 factorial, or you can write n into n minus 1 into n minus 2 factorial, or you can write n into n minus 1 n minus 2 into n minus 3 factorial. So you can stop anywhere, and but you will have to put this sign of factorial where you will stop. So this notation, Christian Kramp introduced this notation. This question may be asked to you in MCQs. The Christian Kramp lived from 1760 to 1826. It is used in finding binomial coefficients. 8th chapter is the chapter of binomial theorem, and in that chapter we calculate the coefficient of the binomial expression, and in that we use this factorial notation. You have to keep this in mind that 0 factorial is equal to 1, and this is the proof of this. We can write n factorial is equal to n into n minus 1, as we have studied here. So dividing both sides by n, n factorial over n is equal to n minus 1 factorial. This n will be cancelled with this n. Now this is n minus 1 factorial is equal to n factorial over n. If putting n is equal to 1 in this equation, we get 1 minus 1 factorial is equal to 1 factorial over 1, and 1 minus 1 factorial is 0. 1 minus 1 is 0, so this is 0 factorial, and right hand side is 1. So 0 factorial is always equal to 1. So using this notation, we will solve some questions of exercise 7.1. So this is question number 1, and its first part is calculate, evaluate 4 factorial. You know that 4 factorial is the product of all the numbers starting from 4 to 1. So we will write 4 factorial as 4, 3, 2, 1 and multiply all these numbers to get the answer, which is 24. Its second part, similarly 6 factorial, product of all the numbers from 6 to 1, and this is equal to 720. Its third part, 8 factorial over 7 factorial. So we will write 8 factorial as 8 multiplied by 7 factorial. We will stop at 7 and we will write 7 factorial because in the denominator is 7 factorial. So this 7 factorial is cancelled with 7 factorial and we are left with 8 only. Its fourth part is 10 factorial over 7 factorial, and this is equal to, expand this 10 factorial and write 10 multiplied by 9 multiplied by 8 multiplied by 7 factorial. Stop here because in the denominator there is 7 factorial. If there is 4 factorial in the denominator, then you will write 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial. Because there is 7 factorial in the denominator, so we stop at 7 factorial. Now this 7 factorial is cancelled with this 7 factorial and we are left with 10, 9 and 8. Multiply 10, 9 and 8, you get 720. Fifth part is same as 11 factorial over 4 factorial into 7 factorial. In the denominator 7 factorial is the larger. 7 is the larger number, so write 11 factorial such that you stop at 7 factorial. So this is 11, 10, 9, 8 and 7 factorial. Over 4 factorial is 4, 3, 2, 1 and 7 factorial as it is. 7 factorial is cancelled with 7 factorial. We are left with the 11, 10, 9, 8 in the numerator and 4, 3, 2, 1 in the denominator. Now cancel the numerator and denominator. 4 is cancelled with the 2. 2 is cancelled with this 2 and 3 is cancelled with 9. 9 is cancelled with 3 and we are left with the 11, 10 and 3. Multiply all these, we get 320. Now this is the sixth part which is included in your smart syllabus. These parts are not included, but this part is included. This part is same as its fifth part. 6 factorial over 3 factorial into 3 factorial. Expand 6 factorial till 3 factorial. 6, 5, 4 and 3 factorial. In the denominator there is 2 times 3 factorial. So 1 3 factorial is written as 3 to 1 and 1 3 factorial is left as it is. This 3 factorial is cancelled with 3 factorial and we are left with the 6, 5, 4 over 3 to 1. This 3 to the 6 is cancelled with this 6, so we are left with 5 into 4 and 5 multiplied by 4 is 20. Seventh part is also included in the smart syllabus, which is 8 factorial over 4 factorial into 2 factorial. So we will write 8 factorial till 4 factorial. This is 8, 7, 6, 5, 4 factorial. In the denominator 4 factorial as it is and write 2 factorial as 2 into 1. This 4 factorial is cancelled with this 4 factorial and this 2 is cancel with 3, or you can cancel 8 with the 2. So 8, 7, 3, 5. Multiply 8, 7, 3, 5, we will get 840. Eighth part is also not included in your syllabus, so you can see the solution from here. Ninth part is your syllabus part. 9 factorial over 2 factorial into 9 minus 2 factorial. Within the bracket there is 9 minus 2. So first simplify within the bracket. We will get 9 factorial over 2 factorial into 7 factorial. Now write 9 factorial as 9 multiplied by 8 multiplied by 7 factorial. And in the denominator write 2 factorial as 2 into 1 and 7 factorial as it is. This 7 factorial is cancelled with 7 factorial and cancel 8 by 2 will get 9 multiplied by 4 and 9 multiplied by 4 is 36. 10th is also your syllabus. 15 factorial over 15 factorial into 15 minus 15 factorial. So we'll write 15 factorial in the numerator as it is, 15 factorial in the denominator as it is, and 15 minus 15 is 0 factorial, and we know that 0 factorial is 1. So 15 factorial is cancelled with 15 factorial, and we are left with the 1 over 0 factorial, and 0 factorial is 1. 1 over 1 is equal to 1. This 11th part is not included in your syllabus, but I have solved it here. You can see 3 factorial over 0 factorial. 3 factorial can be written as 3 to 1, and 0 factorial is 1. So the answer is 6. 4 factorial into 0 factorial into 1 factorial, you can solve this by yourself. The question number 2 of exercise 7.1, write in the factorial form. You are given a question which is 654, and you are asked to write this 654 as a factorial notation. We know that factorial is a notation in which we multiply a number and all the numbers smaller than till 1. So 654 is there, largest number is 6. If we multiply this 654 by 3 to 1, so we can write this as a factorial. So multiplying this with 3 to 1 mean multiply this by 3 factorial. So to maintain the equality, we will have to divide by 3 factorial also. So in the numerator, this is 6, 5, 4, 3, 2, 1. The product of all the numbers from 6 to 1 means this is the factorial of 6. So in the numerator we get factorial of 6. In the denominator this is factorial of 3 or 3 factorial. So we can write this as a factorial notation by multiplying and dividing the missing product, and you cannot cancel 6 with 3. Whenever there is a factorial notation with the number, you cannot cancel the numbers with the other number. You can only cancel by simplifying these two. Now 12, 11, 10. To complete the factorial, we will have to multiply this with the 9 to 1. The product of 9, 8, 7, 6, 5, 4, 3 to 1, or this is 9 factorial. If you multiply this left hand side by 9 factorial, so you have to divide this by 9 factorial as well to keep the equality. So this is equal to numerator, larger number is 12 because this is the product of all the numbers from 12 to 1. So we can write this as 12 factorial, and in the denominator there is 9 factorial. So again you cannot cancel 12 and 9. Part 3 is not in your selected syllabus. So you can solve this as we have done its part 1 and part 2. Fourth part is this: in the numerator there is 10, 9. So multiply this with 8 factorial, and you have to also divide this by 8 factorial. So this is 10, 9 into 8 factorial. This 2 into 1 can be written as 2 factorial, and multiply it with 8 factorial. So in the numerator we get 10 factorial. In the denominator there are 2 factorials. One is 2 factorial and 8 factorial. This is your syllabus question 876, and in the denominator there is 3 to 1. In the numerator the product of numbers from 5 to 1 is missing. That is we will multiply the numerator by 5 factorial, and we will have to divide this also by 5 factorial, and 3 to 1 can be written in factorial form as 3 factorial. So in the numerator we get 8 factorial, in the denominator this is 3 factorial into 5 factorial. Sixth part 51, 52, 51, 50, 49. So all the numbers from 48 to 1 we will multiply this numerator by the product of all the numbers from 48 to 1 to write the numerator as a factorial. So we will multiply the numerator by 48 factorial, and we will have to divide this also by 48 factorial. And this 4321 can be written as 4 factorial. So in the numerator it is the factorial of 52, in the denominator there is 4 factorial and 48 factorial. Seventh part is n into n minus 1, n minus 2. The product of all the numbers starting from n2. To write this as factorial, we will have to multiply all the numbers which are less than n minus 2 till 1. So this is n minus 3 factorial. The number smaller than n minus 2 is n minus 3. So n minus 3 factorial means the product of all the numbers from n minus 3 to 1, and divide it by n minus 3 to maintain the equality. So in the numerator the larger number is n, so numerator is the factorial of n and denominator is the factorial of n minus 3. Eighth part is your syllabus question. There is n plus 2 is the larger number, n plus 1 is the smaller than n plus 2, n plus 1 n is smaller than n plus 1. So we will multiply this by n minus 1 factorial, and we will divide by n minus 1 factorial. The number smaller than n is n minus 1 factorial. So n plus 2, n plus 1, n into n minus 1 factorial. We will divide it by n minus 1 factorial also. So in the numerator we get n plus 2 factorial, and in the denominator we get n minus 1 factorial. So this is equal to n plus 2 factorial over n minus 1 factorial. So these questions may be asked in MCQs as well. So the factorial form of this is equal to, in the option you may be given this one and some other options. Ninth part is n plus 1 n minus 1 factorial over 3 to 1. So what we will write, this is n plus 1 n minus 1 multiplied by n minus 2 factorial. This n minus 1 is n minus 1 factorial is written as n minus 1, and n minus 2, number smaller than n minus 1 is n minus 2 factorial, divided by 3 factorial into n minus 2 factorial. So in the numerator there is n plus 1 factorial over 3 factorial into n minus 2 factorial. 10th part is n into n minus 1, n minus 2 till n minus r plus 1. Now this is the smallest number from these numbers. So what is the smaller than this number? Means you will subtract 1 from this. Subtracting 1 from this plus 1 will be cancelled with minus 1, and you will left with n minus r. So smaller number than n minus r plus 1 is n minus r. So you will multiply the numerator with n minus r factorial, and you will have to divide the at the same time by n minus r factorial. So in the numerator you get n factorial, in the denominator you get n minus r factorial. So this is your exercise number 1, 7.1, and now we will start exercise 7.2. In 7.2 is permutation. The orderly arrangement of object is called permutation. The simplest definition of permutation is the orderly arrangement of objects is called permutation, or arrangement of numbers in which order is important. Then that type of arrangement in which the order of arrangement is important is called permutation. There are different types of permutation. Permutation of n different objects taken all at a time. If you are asked to arrange some objects and you have to take all the objects at a time, then how you will find the number of arrangements? This is the number of permutations or arrangements of n distinct objects when all are taken at a time is n factorial. So n factorial, if there are 5 objects and all the 5 has to be taken, so it means the number of arrangements will be equal to 5 factorial, and we know that how to find the factorial of 5. We will multiply 5, 4, 3, 2, 1, and we will get the answer. So this is permutation of n different objects. All the objects should be different, and if all the objects are to be taken at a time, then number of arrangement is n factorial. Second is permutation of n different objects taken r at a time. You need not to take all the object at a time, but some of them. The objects must be different or distinct. And if you are asked to use any particular number, not all, if there are 5 different objects and you are asked to use 3 of 5, then find how many arrangements can be made. So the formula for this is a permutation of n different objects taken r at a time, where r is less than or equal to n. R cannot be greater than n. This is less than or equal to n. Is an arrangement of the r objects. It is denoted by npr. The permutation of n objects taken r at a time is denoted by this symbol. On the calculator there is this key npr. This is read as permutation of n objects taken r at a time, and the formula by which we will calculate this is npr is equal to the n factorial. In the numerator we will write this number n factorial, and in the denominator is the factorial of the difference of these two numbers n and r. If r is equal to n, then npn is equal to n factorial. So this is the formula. This may be asked in MCQ, and this formula is also asked in MCQs. So we will use these two formulas to find the permutation of n objects when all are taken at a time, and permutation of n different objects when r are taken at a time. Now let's solve some questions of exercise 7.2. Question number 1 is evaluate the following. This is 20p3, that is permutation of 20 objects taken 3 at a time. We know that its expansion is 20 factorial in the numerator, and in the denominator it is the factorial of the difference of these two numbers, 20 minus 3. So solve within the bracket, we get 20 factorial over 17 factorial. Now write 20 factorial such that you stop at 17 factorial. So this is 20 into 19 into 18 into 17 factorial. In the denominator there is 17 factorial. This 17 factorial is cancelled with this 17 factorial, and we are left with 20 into 19 into 18. Multiply 20, 19 into 18, we get 6840. Its third part is permutation of 12 objects taken 5 at a time. So similarly we will write 12 factorial in the numerator and difference of 12 and 5 in the denominator. So 20 factorial over 20 minus 5 factorial. Simplify within the brackets, we get 20 factorial over 15 factorial. Now we will write 20 factorial such that we will stop at 15 factorial, and we get 20, 19, 18, 17, 16 and 15 factorial. In the denominator there is 15 factorial. Cancel this 15 factorial with this 15 factorial, and we are left with 10 into 9 into 8 into 7 into 6 into 5 into 4. Multiply all these numbers by using the calculator, and we get 604800. Its fifth part is permutation of 9 objects taken 8 at a time. So this is equal to 9 factorial over 9 minus 8 factorial. 9 factorial over 1 factorial. So this is the product of 9 to 1. 1 factorial is cancelled with 1 factorial, or 1 factorial is 1. So this we are left with the product of 9, 8, 7, 6, 5, 4, 3, 2. Multiplying all these numbers we will get 362880. This is your answer. In question number 2, you are asked to find the value of n when. This question is very important for your examination point of view. So it's all the three parts are important. Its first part is find the value of n when np2, that is permutation of n object taken 2 at a time, is equal to 30. This is an equation. To solve this equation, we will use the formula to write permutation of n objects by 2, which we have studied, and this is equal to n factorial over n minus 2 factorial equals to 30. Now n factorial, and in the denominator there is n minus 2 factorial. So write n factorial such that you stop at n minus 2. So we get n into n minus 1 into n minus 2 factorial. In the denominator there is n minus 2 factorial, and this is equal to 30. This n minus 2 factorial is cancelled with n minus 2 factorial, and we are left with n into n minus 1 is equal to 30. Now there are two factors, n and n minus 1, two consecutive numbers, n and a smaller number, n minus 1. So 30 can be written as 6 into 5, the product of two consecutive numbers. Now here n is equal to 6 and n minus 1 is equal to 5. So comparing these two sides, we get n is equal to 6. So this is important part for your examination point of view, and this question is often set in short questions. Its second part is permutation of 11 objects taken n at a time equals to 11, 10, 9. So because this is an equation, we will write its left hand side by using the formula, this one. So this is 11, 10, 9, 8 factorial over n minus 11 minus n factorial. That is, in the numerator there will be 11 factorial over 11 minus n factorial. So 11 factorial can be written as 11, 10, 9 and 8 factorial, because in the right hand side of this equation there are 11, 10 and 9. So this 11, 10 and 9 will be cancelled with each other, and we will get with 8 factorial over 11 minus n factorial is equal to 1. This 11, 10, 9 are cancelled with 11, 10 and 9. 8 factorial over 11 minus n factorial. Cross multiplying, we get 8 factorial is equal to 11 minus n factorial. Because this is an equation, so it means the left hand side and right hand side are equal to left. So we will put 8 is equal to 11 minus n. This equality will hold when the factorial 8 will be equal to 11 minus n. If we can replace 11 minus n by 8, then both sides will be equal. So if we write 11 minus n equal to 8, and solving this equation, we will get the value of n. N is equal to 11 minus 8 and n is equal to 3. Third part is, now left hand side is a ratio and 9 hand side is also a ratio. This is np4, permutation of n objects taken 4 at a time, and permutation of n minus 1 objects taken 3 at a time is equal to 9 ratio 1. The ratio between these two permutation is equal to 9 into 1. You can write this in a fraction form, because every ratio can be written in fraction form. np4 over n minus 1 p3 is equal to 9 over 1. Now np4 is equal to 9 into n p n minus 1 3, that is permutation of n minus 1 object taken 3 at a time, cross multiplying. Now use formula. NP4 is n factorial over n minus 4 factorial is equal to 9 into n minus 1 factorial over n minus 1 minus 3 factorial. Simplifying this, n into n minus 1 factorial over n minus 4 factorial is equal to 9 into n minus 1 factorial over n minus 4 factorial. Look, this n minus 4 factorial is cancelled with this n minus 4 factorial. If you compare both these sides, left and right hand side of this equation, n minus 1 factorial, n minus 1 factorial in the numerator, n minus 4, n minus 4 factorial in the denominator. So it means there is n and there is 9. So this n minus 1 factorial is cancelled with this, n minus 4 factorial is cancelled with this, and we are left with n is equal to 9. So our answer is 9. All these three parts are important for your examination point of view. All these three parts are very important for your examination point of view. This is question number 3. Prove from the first principle that NPR is equal to n into n minus 1 PR minus 1. Take its right hand side. This is n into n minus 1 PR minus 1. Use the formula to write this, which is n into n minus 1 factorial, and in the denominator we will take the factorial of n minus the difference of these two. So this is n into n minus 1 over n minus 1 minus r minus 1, n into n minus 1 factorial over n minus 1 minus r plus 1 factorial here, and we are left with n factorial over n minus r factorial, and this is the formula of NPR, which is our left hand side. Its second part is NPR is equal to n minus 1 PR plus r into n minus 1 PR minus 1. Take its right hand side and use formula to write n minus 1 PR in this form, n minus 1 factorial in the numerator and the difference of these two, factorial of the difference of these two in the denominator, plus r into n minus 1 factorial over the factorial of the difference of these two in the denominator. So we get n minus 1 factorial in the numerator and n minus 1 minus r factorial in the denominator, plus r into n minus 1 factorial. Minus 1 is cancelled with plus 1, and we are left with n minus r factorial. So this is n minus 1 factorial over n minus r minus 1 factorial plus r, n minus 1 factorial over n minus r and n minus r minus 1 factorial, because in the denominator of this there is n minus r minus 1, so we have expanded this n minus r to this. Now take n minus 1 factorial over n minus r minus 1 factorial common, and we are left with 1 from here, and r into 1 over n minus r. Take the LCM of the two terms within the brackets. N minus r is the LCM, so we get n minus r plus r. This plus r and minus r is cancelled, and we get n minus 1 factorial over n minus r minus 1 factorial. Within bracket we get n over n minus r. So this is n into n minus 1 factorial and n minus r into n minus r minus 1 factorial. So in the numerator the larger number is n, and it is the product of all the numbers from n to 1. In the denominator n minus r is the larger number. So in the numerator we can write n factorial, in the denominator we can write n minus r factorial, and this is the formula of NPR. So n factorial over n minus r factorial is equal to NPR, and this is our left hand side which we have to